Hey guys, welcome to MeiCode.org. My name is Maysam, and in this video we are going to talk about async task. For those of you who don't know what an async task is, let's talk a few moments about the async task. Whenever you run your Android application, that application by default would be executed in the main thread. Of course, you can change that behavior, but this is the default case. For those of you who don't know the meaning of a thread is a unit of execution in the central processing unit or CPU of your device. Basically, different threads come together inside a process, meaning that a process can have one or multiple threads. Later on, that process, among other processes, will be processed by the central processing unit of your device, or you might heard of it as the CPU. By default, when you run your Android application, a thread will be created. We know that thread as the main thread, or some might call it the UI thread, the user interface thread. For some applications, that main thread is enough and you don't need to create another thread. But for the applications that are doing some heavy stuff, you need to create another thread. But what happens if you do the heavy stuff, like downloading a file, like converting some bitmap image in the main thread? In that case, the user interface is going to be blocked, meaning that until the job of the thread, the heavy stuff that we were talking about, is not finished, the user is not going to be able to interact with our application. In fact, there is a limitation for blocking the UI thread. Right now, that limitation is 5 seconds, meaning that if you block the user for 5 seconds or more, the user will get an ANR dialog, or some might call it the application not responding dialog, and your application will be closed. We don't want that behavior in our applications. So in order to do the heavy stuff, like downloading a file, like converting different files, we don't want that in our application. The solution in here is to create another thread and do the heavy stuff like downloading a file or converting a file inside that thread. This way we won't block the user from interacting with our application. There are few basic ways to create and handle working with that worker thread. For example, you can simply say thread is equal to new thread and hand over your job to that thread. But if you use that basic way, there are a lot of considerations that you need to be worried about. For example, you need to be worried about when to start your thread, when to finish your thread, when to cancel your thread. Also, we have something called a thread pool, which different threads come together inside that pool. I don't intend to talk about those considerations in this video. Instead, I'm going to talk about async task, which is a better and simpler way to work with different threads. So now we know the usage of an async task. Let's create one. We can create an async task like any other Java class. I can right click on my package by selecting new, and Java class, I can create that class. Let's call this class example async task. In here we need to extend the async task class. But that's not all. We can also pass parameters to this class as well, and we pass them inside these diamonds. We can pass 3 parameters to our async task. The first parameter is the input of our async task. The second one is the progress of our async task, and also we can pass a result to our async task as well. For example, in here I can pass integer. Notice that I can't pass primitive data types in here. For example, I can't say int. Instead, I'm going to use the Java class. I can say integer. If you don't want to pass anything as the input, progress, or the result of your async task, you can pass void. That's going to work fine as well. But in this case, I'm going to pass integer, and later on we will see why. For the progress and result, I'm going to pass void. It should be in with capital V. As you can see, I'm getting a warning in here, and that's because when you extend the async task class, there is one mandatory method that you need to override, and that's doing background. You can override that by pressing Ctrl O and selecting the doing background method. So we don't need to be worried about anything. This method is going to create another thread for us. Also, it will finish or cancel the thread whenever it's done with it. You can do whatever you want inside this doing background. For example, you can download a file in here. In this simple application, I don't want to download anything. Instead, I'm going to log something. So let's add a log up in here, log t pressing tab. And down in here, inside the doing background method, I'm going to create a for loop. As you can see, we are receiving some integers in shape of arguments as the input of this doing background method. And this integer is exactly what we have put up in here as the input type of our async task. I can use these integers. For example, I can say for int I is equal to, let's say, integers with an index of 0. Basically, we are going to pass only one integer to this async task, but of course you can pass more. In this case, I'm going to pass only one integer, so its index would be 0. For the condition of this for loop, I'm going to say do the loop while I is less than 0. Basically, I'm going to count down from the input that is going to be passed to this method, for example, from 10 to 0. So this would be our condition. And for the third argument in here, I'm going to say I minus minus. After that, I'm going to say log the value of I. I can say log d, let's say I plus the I. Also, because we are not doing any heavy stuff in here, for example, downloading a file, manually I'm going to sleep the thread in here. If we do this sleep inside the main thread, the UI will be blocked. We are just going to see that if our UI is going to be blocked in here. For sleeping the thread, I can say system clock this one dot sleep for, let's say, 1000 milliseconds. So basically we are going to count down from, let's say, 10 to 0, and we are going to wait 1 second for the next number. That's all we need to do in order to create an async task. We have a lot more functionalities. We are going to talk about them in a few minutes, but for now let's just call our async task. In my main activity, I can say example async task. Let's call it example async task is equal to new example async task like any other Java class. And after that, I can say example async task dot execute. Right now, the IntelliJ is happy with this way of declaring and executing our async task, but we know that we have set integers as the input of our async task. So I'm going to pass 10 in here as the input. We don't have any user interface for our application, so I'm going to open the logcat. As you can see, we are logging the value of I every second. But what if you want to update the user interface with the help of the async task? For example, you want to show some progress bar when you are working with your application. For that reason, I'm going to create an inner class inside my main activity. In here, I can say private class. Let's call it inner async task. It needs to extend the async task once again. We have 3 parameters. This time I'm going to pass integer for the input, I'm going to pass integer for the progress, and also I'm going to pass a string as the data type of the result of this async task. Once again, we need to override the doing background method. Before we start working on this inner async task, I'm going to change the layout of my main activity. Basically, I'm going to add a text view and a spinner. The reason for the spinner is that I'm going to show you that the user interface won't be blocked. In order to save your time, I have prepared this layout file, a text view for the number and also a spinner. Also, I have created a string array for different entries of this spinner. And if you want to check the string array, inside the values, strings, you can see this string array. Okay, let's initialize these items inside my main activity. Our layout is ready. Let's switch back to our async task. In here, inside the async task, beside this doing background, which is the mandatory method, we have other methods as well. If you press Ctrl O once again, you can see few of those methods. Some useful methods in here is this on pre-execute, on post-execute, on progress update, and on cancelled. Let's override the first three and let's talk about them a little bit. So this onPreExecute method will be executed before doing background, meaning that if you want to have any sort of initializing, you can do it in here. For example, I can move the initializing of this text view to inside this onPreExecute method after the super statement. The next one, onPostExecute, as its name applies, is going to happen after the doing background. You can see the input of this method, which is a string in this case, and this is exactly what we have put as the result of our async task. In order to have a better grasp, I'm going to move this method after the doing background. It's not going to change the code anyway, it's just better for eyes to follow. The next one, this onProgress update, is responsible for updating the progress of our async task. For example, if you are showing a progress bar, you can use this method in order to update the progress of that progress bar, for example, every second. I'm going to move this one after the doing background as well. But there is a very important point in here, and that's among all of these methods, only the doing background is going to happen inside a worker thread. All the others are going to happen inside the UI thread. So don't do any heavy stuff in any of these three methods: onPreExecute, onProgress update, and onPostExecute. As I said, I'm going to count down from 10, for example, to 0. So I need to create my for loop inside the doing background. I can say for int I is equal to the integers that has been passed to this method with an index of 0, which would be the first and only number, until I is bigger than or equal to 0 and I minus minus. In here I'm going to sleep the thread once again. Let's say system clock.sleep for 1 second or 1000 milliseconds. After that, I can use publish progress method in order to publish the progress of my async task. You can see that it's waiting for some integer, and this is exactly what we have put in here as the progress of our async task. For the progress of this async task, I'm going to pass I, and this I will be passed to this onProgress update method. Once again, you can see that in here we are receiving some integers. As I said, this onProgress update is going to happen in the UI thread, so it's a good point to update our text view. I can say txt number.setText to a string.value of values with an index of 0, which is this integer argument that has been passed to this method. After the job of this async task is finished, the onPostExecute method is going to be called, and in here we can say txt number.setText to, let's say, finished. Instead of passing this text in here manually, we can use this string that has been passed to this method. And this string is going to come from the doing background method. As you can see, the return type of this doing background method is a string, and we can return a string from this method. Let's say finished in here. Later on, instead of passing finished in here, I can say s. Okay, that's all we need to do inside our async task. Let's just call it from our onCreate method. I'm going to comment the previous async task down in here. Once again, I can say inner async task. Inner async task is equal to new inner async task. I can say inner async task.execute, and I need to pass a number, which I'm going to pass 10. Let's run the application and see how does it look. As you can see, the countdown has begun, and if we try to work with our application, you can see that we can do it, and the UI hasn't been blocked. After finishing the countdown, we are seeing the finished message. Perfect. There is just one more thing that I need to talk about related to the async task, and that's this warning in here. You can see that it says leaks might occur. It's referring to the memory leaks, But before I talk about memory leaks that can cause by async task, I'm going to ask you to subscribe to the channel if you haven't already. I'm uploading content on a daily basis, and also if you like this video, please hit that like button. It's going to help me a lot with the YouTube algorithm. Okay, let's talk about the memory leaks that can cause by async task. Whenever you are defining a new object like we are doing in here, or even whenever you are defining a new primitive data type, that primitive data type or object is going to occupy some memory space inside your device's memory RAM. In a normal application, that allocated space in the device's memory is going to free up whenever you are done working with that primitive data type or object. And that process is going to be handled by something called garbage collector. But if for any reason, if the garbage collector wouldn't be able to free up that space, we are going to occupy more memory RAM that we need. And that's called a memory leak. If that becomes a repetitive behavior by our application, that space is going to increase, and in some cases the Android system might warn the user that that application is using too much memory RAM. We don't want that behavior in our application. But why is this memory leak happening in here? Well, because we are creating a new thread in here inside this doing background, and the life of that thread might be much more than the life of the application itself. It means that if we run our activity in this case, and if we call our async task.execute method, and immediately after that we close our application or anyhow we destroy the activity, this thread is going to still be running in the background. It means that it's not going to free up the resources inside the memory RAM. The destroying of an activity is not going to happen only by closing the application. It might happen in case of changing the device's configuration. For example, if we rotate the device, we know that the activity will be destroyed and after that will be recreated. Also, we might navigate the user to different part of our application. In those cases, our activity might be destroyed, but this async task might not, and its allocated memory RAM might not free up. So it's going to cause memory leaks. There are few solutions for this problem. The easiest one is to make this class a static class. So in here I can say private static class. We know that whenever we define a primitive data type or an object as a static, there would be only one instance of that object or primitive data type in our application. But as you can see in here, when I define the type of this class to a static, I can't have access to my UI elements, and that's because my onCreate method is not a static, and as you can see the error in here, non-static fields cannot be referenced from a static context. Defining your class static is going to be helpful whenever you are not working with the UI elements, for example, whenever you are downloading some file, but it's not going to help us in this case in this application. There is another option. Depending on your need, you can cancel your async task in different parts. For example, I'm going to cancel my async task in onDestroy method. For that reason, I'm going to define this async task as a member variable. I'm going to delete the definition from here, and I'm going to move it up in here. Let's say private inner async task, so that we could have access to this inner async task from two different methods, onCreate and onDestroy. Let's override the onDestroy. After the super statement, first of all, I need to check that my inner async task is null or not. I can say if null is not equal to inner async task, then I can say inner async task.cancel. You can see that this cancel is asking for a boolean, and the boolean name is main_interrupt if running. It means that do you want to cancel your async task even if it's still running or not? You can pass true or false in here depending on your need. I'm going to pass true in this case. We are still seeing the warning in here, but we know for sure that whenever we destroy our activity, our async task is going to be cancelled. So that wouldn't cause memory leaks. In order to test my application and see if this cancel method is going to work or not, I'm going to add some logging. First of all, let's add log t up in here. And down in here, inside the onProgress update method, I'm going to add the log. I'm going to say log d, let's say progress, and we need to pass values with an index of 0. Let's run the application and see how is it going to behave. We need to open the logcat. You can see that the countdown has begun. Let's try closing our application. You can see that the process has been stopped. It means that the async task has been cancelled successfully. So we are not going to cause any memory leak. Okay, this was the way you could have worked with async task. If you have any question, please leave them on the comments below. I'm reading all of the comments and I'm more than happy to answer your questions. Just before I finish off this video, I'm going to ask you to subscribe to the channel if you haven't already. I'm uploading new content on a daily basis. And please hit that like button if you like the video. It's going to help me a lot with the YouTube algorithm. Thanks for watching. Thank you for watching. I hope you enjoyed this video. If you did, I have 100 more hours of content like this in the format of a course on my website. To this day, 30,000 students have enrolled in the course, and I believe if you want to learn Android app development in a professional manner, you would check the course at MeiCode.org. Besides Android app development, there are a lot more courses from me and other professional instructors on the website, like Java, Python, hacking, and different kind of marketing, which you can check if you are interested. See you guys in the next video.